Some of the parts that we did, we were taking old programs that we were running for years and changing them from 40 minutes to, in some cases, 22 minutes. Almost a 50% increase right off the bat. Some of the parts that we did, we were taking old programs that we were running for years and changing them from 40 minutes to, in some cases, 22 minutes. Almost a 50% increase right off the bat.
The biggest problem we got right now in roughing out these billet blocks is the chip conveyor won't keep up.
Biggest reason to use Mastercam? Flexibility. You wouldn't believe what the energy industry can throw at us.
What used to take the clinician 8 to 12 hours, now we're using Mastercam to turn that time around into 1 or 2 hours.
Good morning all. I heartily welcome all the participants, those who have joined for today's session. Myself, Dr. Sachin Ingole, heading Mechanical Engineering Department of Sipna College of Engineering Technology, Amravati. Friends, most of you are well known about the fact that Sipna College of Engineering is one of the leading institutes in Maharashtra region and marching ahead toward excellence under the dynamic spiritual leadership of Honorable President Sri Jagdish Gupta sir and respected Principal Dr. S.M. Kherde sir. Friends, we are the NBA and NAC accredited institute and highly qualified, experienced and retained staff is the strength of the institute. I am thankful to the team of Deccan IT Technologies and specially Engineer Nitin Vakode sir for extending their hands for jointly organizing webinar on CAD CAM and CAE. I am having personally long association with Engineer Nitin Vakode sir. He is having a vast experience in the field of CAD CAM, industrial automation and robotics. Engineer Nitin Vakode plays an important role in augmenting the concept of Industry 4.0 in India. Presently, world is facing the problem of COVID-19 pandemic and everyone is taking the precaution to prevent from corona infection. Social distancing and distance education are the today's buzzwords. In India, presently MNCs and big industries are adopted the concept of CAD CAM CE through their own setup or hiring the services from other organizations. But in future, due to initiative taken by Government of India to uplift and promote small and medium scale organization through Atmanirbhar Bharat will be diverted toward this practice and large human resources demand will be created in this particular domain. I am damn sure that after attending this webinar, one another buzzword will be added in your dictionary, that is distance manufacturing. With this, I conclude my introductory part and hand over this session to today's speaker, Engineer Nitin Vakode sir. Once again, thank you very much for having with us. Thank you.
Good afternoon everyone. Let me introduce you to Mr. Nitin Vakode, Director of Deccan IT Technologies, Skyleap Technologies. He has completed his graduation in BE Production Engineering, post-graduation in ME Mechanical with specialization, PhD in pursuing in CNC machining parameters of optimization area. Areas of experience: Industry 4.0, robotics, CNC manufacturing, product design and tooling development, stimulation. Total industrial experience is of 24 years, 2 years as a director with Deccan IT Technologies, Skyleap Technologies, 13 years, that is to July 2005 to April 2018 with Onwards Technology Limited, Associate Vice President PSG. 8 years, that is August 1997 to July 2005 experience, German tool room Aurangabad in German precision and tooling manufacturing. 1 year, that is July 1996 to July 1997 with Aditya Birla Group, CNC manufacturing in hardcore expertise in CNC, programming and manufacturing, CNC milling, 2 to 5 axis milling, turning, Mastercam programming, CAD, CAM and CAE, knowledge about cutting tools and its parameters, CNC controller programming, programming for various machines like DMG, HAAS, Fager, Thermwood, BFW, Jyoti, Okuma, Mitsubishi. Metrology CMM expert, domain expertise in plastic mold manufacturing, sheet metal dies, casting dies, component development, robot programming, expertise in executing CAM projects using Mastercam, UG, NX, CAD and CAM, Vericut, CATIA V5s, SolidWorks, NC, CMU. International exposure for business, seminars, training in USA, Germany, Italy, UAE, Sri Lanka, Saudi Arabia, Qatar and Malaysia. As extracurricular activity to support academic, actively involved in providing technical lectures, training, curriculum development, CAD, CAM and CAE manufacturing with Indo-German tool room, CITD, GTTC. Supported Board of Studies, Savitribai Phule University, industry member, Raisoni College of Engineering, Waguri, Pune, BOS member, Vishwakarma University, Pune Management Studies and BOS member. Certifications in plastics and mold design, certification GTZ Germany, CMM inspection, Carl Zeiss 6-week training, SolidWorks certification, AVA certification, Vericut certified to iOS auditor. Thank you.
Thank you, Nitin sir, and good morning to all of you. So, as you can see that first machining operation in mailing, so we have to do first face toolpath or facing operation. So this facing operation we need some basic parameters. Okay. So what is face toolpath? Like in this toolpath, one can quickly clean the stock from the top of the part and create an even surface for future operation. You can pass the toolpath or either change geometry or on the current stock model. So there are some given basic parameters like across, along overlap, approach distance, exit distance and step over. Similar to that, for the facing operation you will get some uh, types of facing toolpath like zigzag, one way and dynamic and one pass. This is the toolpath way. Okay, so given side there is a simulation video for the facing toolpath. You can see, I'm just playing that. Okay, this is our facing operation, and this toolpath is like a zigzag. Okay, so let me show you the Mastercam interface 2020. As you can see, there is a model, existing model. On this existing model, I have to create a facing operations. So first of all, for the facing operation, so we have to do first stock setup. Okay, for the stock setup, we have to go to the toolpath manager. In this toolpath manager, you will get properties, and in this properties, you have to set the stock setup. For the stock setup, we have to select the all entities, and after that, give the value of Z for the facing. Okay, I have given that and display that. After that, click on OK. After that, after OK, you will get the wireframe stock. Okay, this is our extra Z value 2 mm. And after that, go for the operation from 2D toolpaths. Here you will get so many of toolpaths like contour, drill, dynamic mill, facing, dynamic contour, pocket, wheel mill. There are various type of toolpath in 2D. Okay, so first face, after click on the face toolpath, you will get a window for the chain selection. Okay, here we will get so many type of method for the selection, and we have to select the chain. After selecting the chain, you have to click on that. Okay, and okay, and after that you will get a window of 2D toolpath facing, and according to your application you have to select the toolpath type, which toolpath you are doing now. So I have to do facing, so I have selected face, and Next, we have to select the tool. In this tool, you can see that there are various types of parameters like tool diameter, corner radius, tool name, tool offset, length offset, head, diameter offset. There are the various cutting parameters, tool parameters are there. Okay, according to your application, you can given the value of tool parameters or cutting parameters. And in this comment box, you can write anything to for the operator. Like this, for example, I'm writing here that fetching width as for my tool that I am using or I will use. Okay, so for the tool, you have to go to the standard tool library. Go to the standard tool library, you have to click on this select library tool. After select library tool, you will get there are a lot of tool. Okay, if you want to filter that, you can also filter. So after selecting filter, I just got a face tool of 50 diameter and click on OK. And you can modify also that. On the right click of the tool, you will go for the edit tool, and here cutting, you will get cutting diameter, secondary diameter, overall length, cutting length. Okay, and which type of corner type you have on your tool, you can give also that. After that, finish on that, and just in comment I have just writing that facing with 50 mm tool. Okay, and coming to the next in holder, as for your facility or as for your availability of holder, you can select the holder. Okay, I have selected BTC30016. And coming to the next parameters, in cutting parameters, you will get the style that I have uh, told you in PPT, that you will get there are 4 types of style like zigzag, 1x1 pass, dynamic. Okay, basically the most preferred is zigzag, preferable style is zigzag, and here we will get the across overlap, along overlap, approach distance, exit distance. Okay, and step over also. After that, here you can see that climb and conventional like up milling and down milling. And after that, if you want to stock to live on floors, then you can give that value or 0. Okay, after that, coming to the depth of cuts, in depth of cuts you can provide your depth of cuts value, like I am just providing 0.5. After that, keep tool done. If you are selecting this keep tool done, then your tool not repeated time for the retraction or clearance. Okay, and coming to the next, in linking parameters, this is the most important parameters. So in the linking parameters, you have to select clearance. You can give the value of clearance, and all you have to set in absolute. Fit plane, it's okay with incremental, and depth also in absolute. Okay, so as you know that it automatically select the top of stock. As you know, we have given the Z value +2, so it automatically generate that 2. And after that, we have to select we have to just OK on this, and you will see the
These
tool
are
path here.
actually required for
Okay.
usually every part.
And this is our along overlap, this is our across overlap. Okay, so let me show you the 2D toolpath of this facing operation. Click on this black plot, and you will get the 2D toolpath, how it generated.
It's a kind of a simulation.
Just
It will give you the realistic view
that how it
is getting cutting.
cut that material for the facing toolpath. This is our 50% across overlap.
Just check.
This is a along overlap. Okay, and if you want to see in this 3D simulation window, then you have to go for this verify, and after the selecting this verify, you will get another window for the simulation. Okay, as you can see, this is our 3D simulation window, and I just decrease the motion of the tool, cutting tool, and in this window you will get so many informations like move ID, move type, and what type of operations that you are doing, and operation name, which type of tool that we are using. Okay, there are various type of information
Yeah, this
that
is
we
a
will get.
simulator window.
Okay, this is our simulation window. Let me start the operation. As you can see, the tool is coming downward.
These are usually a face tool which
Cutting
will cut
as per our
a large
given
amount
depth
of
of cut.
material in a one pass.
Given style, the cutting method.
Sometimes the shear cutters are there, sometimes round inset cutters are there.
So this is it our for the facing operation. Okay, and if we are talking about the ANSI code generate, how it generate, then for the ANSI code generating, you just have to click on this post selected operation, that G1 on G1. Just click on this, and post processing you have to click on the ANSI file and OK. And after the OK, he will ask for the root where the file will be saved. Okay, and I just that will be on the desktop and save. After that, you will get a Mastercam code expert window, or in this code expert window you will get your ANSI code. All
This is the program
as per your
which
comment, you will
programmer
get
can
this.
use on any CNC machine,
Just see.
and we
Okay,
will customize that codes as per the requirement. Any such kind of NC program, we usually customize as per the machines. So many a times machines are like a complex machine, which can be a multitasking machine or multi-access machine. So it all depends what type of machine it is. We always take the references from the machine manufacturers, what kind of a codes it accepts, what kind of a configuration it has. Okay, so this was just one small example in this in order to show you how manufacturing. But many of people don't has always a question that how much manufacturing is important, because since almost 2000 many of the people have forget the importance of manufacturing, and people always talk of IT. But we should definitely understand, if IT has grown so much, IT has given us so much of good advantages, so why can't we utilize those advantages into manufacturing as well? So the same thing has been adopted by the entire world, but whereas we in India are a bit lagging in that. Though like the premier institutions as well as the good organizations like Tata Motors, L&T, all such companies are using, but the very small scale industries in the other parts of India, though Mumbai, Gujarat, Bangalore, Chennai, even if it's a small shop with one machine is there, they are still using CAD/CAM interface and producing the parts as per the required quality. As Dr. Sachin Ingole has expressed during his first initial introduction, in which he has explained about the Atmanirbhar Bharat, definitely Prime Minister Modi ji has given a very good signals to the Indian industry to gear up to the requirement of the national requirement, consumer requirements, because it is actually a matter of shame for all of us that almost everything is getting imported from our neighbor China, and we are totally dependent on them. We do have a basic infrastructure, we do have industries, but still we keep on importing. Even the Ganapati idol is being imported from China. A small PPE kit is being imported from China. Hand gloves, mask. What do we need China for that? I don't say that we should 100% ban the imports, but at what contrary? We must understand and make a balance. How much we are able to produce, how much chance we are able to give to the local industry for manufacturing, and then based on that, we should always, every country always monitor how much they are exporting and how much they are importing. If there is a good balance between that, then it's a healthy situation. We are competing or we are participating in global economy. That's good. Okay. So in this scenario, ever since this now buzzword has come up, so the local manufacturer have tighten their shoes and start working on waffling towards this activity. And when we talk of complex parts machining, so it has to be supported by the very efficient softwares which can handle the programming part of it. The same way, like we know that why we are looking towards manufacturing. So as we saw that the India is moving towards manufacturing, so we should also have a certain focus on manufacturing, not just the IT, because there are jobs in IT, but in coming time manufacturing is going to be a boom time. Okay, so even if you consider any of the industry, even a mechanical engineer usually thinks that I should do only the ANSYS, I should do only certain CAD, I should become a designer. Nothing wrong in that, but the amount of employment available must be understood by the students, parents. Expectation must be altered accordingly. Industry manufacturing certain item will require maybe 2 or 10 engineers to design it, maybe 2 to 5 people to analyze it, plus, but at the same time 200 plus engineers for programming, CNC programming. Because what happened, programming of CNC machine is a little bit like complex. It requires a lot of strategies, tool selection, cutting parameters, materials, so many complex parameters are involved in. So that is the reason, even if a programmer require almost 6 hours to program that with the various tool path, various strategies, depth of cuts, simulation, timing and all that, but on machine that part will get actually cut in 30 minutes. So can you imagine, for one machine, if one programmer is there and one machine is there, 6 hours is taken for programming and 30 minutes is taken for machining. So what will happen to that machine for the 5.5 hours? It is going to remain idle. So what does that mean? One machine might require 6 programmers to run it in a full efficiency. Because even if you take a case like a machine hour rate is close to 1000, 1200, something like that for CNC machines, and employee man-hour rate is not that high as compared to the machine, and if the productivities can be increased, why can't we do that? So the same concept has been adopted now by the industry, and now per machine programmers, they are ramping up like anything. So the same thing we must understand, and also try to give a knowledge about CNC programming to the students, and that will help them industry ready when they go to the industries. So many times even a programmer, a designer who want to do a design, definitely, but unless and until he understand how the part will be manufactured, whether the part will be able to manufacture, which type of machine it will be machined on, some part which is a fantastic looking design but cannot be manufactured. Is it useful? No, because the part, any product which is designed must be manufacturable, and when the designer will be able to understand what is going to be manufactured out of my design, he will not have that understanding. So friends, very very important for any designer to make him understand properly the manufacturing concept, the various manufacturing concept. maybe a casting, maybe a forging, a plastic injection molding, anything, but all that will require a die tool. So that tool will require to be machined on a CNC machine, milling machine or turning machine or multitasking machine. So such things are very important for even for the designer. And in fact, as we say, like if a programmer's requirement is huge, definitely we can think of that. Many a times it's a very sad story. I have seen many students, engineering students who learn engineering, but now gone into some trade of a grocery shop, or somebody has started medical stores, or somebody has started something like that. That's a very sad part of it, because India has invested a time on you to make an engineer in your institution, your professors. You have paid fees for it, and now you have put up your weapons down, and now you want to do something else. So that way we should try to stick to our disciplines and try to do something better out of it. So that is one aspect of it. And in order to make students industry ready, why there is a huge requirement in industry, but still you are not eligible for that employability. What is the reason behind that? Many professors ask, even in some programs, even I discussed this with many experts on that. So fact is that what is required by industry is not with you. So you must just understand what is required by them. Usually when our engineers go to the industries, they are usually considered as good as an RD. So we must understand what is required. So one example I gave in some of my sessions earlier, like when the doctor learn in one medical college, when he is undergoing his education right from the second year itself, he has a attached hospital to it. So what he do? He start going to the hospital. He keep watching the doctor, what kind of a diagnosis he is doing, what treatment he is doing. Whether he is asking for showing the tongue, looking at eyes, temperature, blood pressure, all such parameters he start understanding. So what happens? The lingo or the vocabulary or entire thing which is required for a doctor, he is learning from second year. So by the time he is second year, third year, fourth year, so almost he is ready to treat a patient. So he is no longer an RD. Whereas our engineer, what he do? He keep on learning one subject to another subject to third subject, fourth subject, but never try to understand what he is expected to do in industry. Some of the students try, that's a very good part of it, but majority of them miss the bus. And then the fact is that they are considered as a raw input for the industry. So in this regard, many of the institutions have already started working on it. We know that we can't have a hospital, the same thing like entire industry set up in the institution, but definitely we have a small sort of prototypes, small machines, small equipment, and then making them to work on the realistic projects. So that will help them get a confidence. That sheer confidence will make them talk the same vocabulary. If he goes to a certain industry, he worked on certain automation setup of maybe hydraulics or pneumatics, making circuits and all that. When he goes to the industry and when somebody asks you double acting cylinder, they immediately will say, yes sir, this can be used like this, or there is a solenoid like this, or there are the two-way valve, three-way valve. So whatever are there, if the PLC is there, he says, yes, I know Siemens S7300 or S74 1200, how to program that. So that vocabulary, if he is able to get in institution, the same, once he talk, they will not consider him orphan. Otherwise, even during the internship, students go to the industries, they are asked to sit in the corner as a white collar engineer, sit there, watch at the entire setup. You are an engineer, just watch. He feels that yes, I am an engineer and I am not able, I don't have to do anything physically. He feels pride in that, but it's kind of a making him fool. Don't touch that because you will spoil that or you will have any trouble in the manufacturing. So my friends, we must understand, even if somebody is not telling, we have to understand what is good for us and how we should take our direction to the right direction. If we are walking on the right and industry is walking on left, it is going to have a huge continuous gap between. So we must look at the industry. If the industry is walking north, we must walk north. Then only we will be in the same boat. Okay. So there are many things out of that. We know that there are many activities like the industrialization, as we say that industry 4.0, all that has started, even industry 5.0 has started. So aspect of is that like product development has a drastic change, because when the earlier era, when you saw that the products were very sturdy, a life of product was very good, but the cost of product was also very high. It was not affordable to the common people. If a Bajaj scooter, you was expected to book very well in advance, and then only you was able to get that. For Fiat, Padmini, Premier Padmini was owned by very premium people only. Ambassador was owned by very premium people. But later on, as the time goes, competition has increased, the price has won over the other aspects. So gradually, there is a tremendous pressure on industry to produce the similar parts with a lower cost. Then the lower cost comes in, factor of safety has to be reduced, because the sheet metal thickness which was earlier used, now we have to reduce it. The plastic parts or the number of parts which were earlier huge, with the correct factor of safety, again material reduction. So even if you take a case of Tata Nano, so where even the tire usually has got 4 bolts, so they have made it to the 3. So there are many such things keep on happening when the product is expected to get at a very lower cost. So this at the same time also had another challenge. You can't have the same product for over the years. Like earlier, the Premier Padmini was used to be only car. There was another ambassador for many years. There was a Rajdoot, same model for many years. Bullet was the same model for so many years. But now it is not the case. Customers' taste is changing day by day. People want a new model to be used. So it is not the old era when the same products were keep on using the same way. It was not a customer centric. What I produce is to be used by the market, whether you like it or not. But today, the companies are talking of user experience. Requirement of customer is the prime. Because if you are not able to produce it or offer it, there are n number of other sellers who are able to provide that. So it is up to the manufacturers whether they want to be in a competition or lag. So if you see the companies who don't change themselves are vanished. The Kodak, a very big brand in the camera, is vanished. Premier, Ambassador brand, you don't see them. There are many, even the global brands, those who were there and now vanished. the transition to the market has changed drastically. Earlier, when one product was used to come to reach to the 100 million customer, it was used to take almost 2 years, 3 years like that. But later on, right from the days when the internet started, the products are reaching very fast to the customers. The computers were reached to the market 1 million customer in a very short time. Mobiles even reach in a very shorter time. The games like your Pokemon Go or the newer games, Clash of Clans and all that, they reach 1 million customer in less than a week. So that makes a difference, that what kind of strategies you are implementing. So another aspect of it, the companies are also service based. The Uber with not a single car ownership is the biggest service provider in the taxi. So these are the things what we must understand. Even from the manufacturing point of view, when you say that earlier you used to have only a normal 3-axis machine, normal 2.5-axis lathe, but because of the complexity of the parts, the two operations are expected to be on the same machine. So that it becomes a turn mill machine. And the machine is expected to more than that. So then it becomes a multitasking machine. So there are different machines which are coming in market with a lot of varieties. Parts are getting manufactured as per the customer requirement, tests. Okay. So the same way, like we'll move towards little bit how we can move towards the machining. So this is the Mastercam is a tool which actually produced by CNC Software, has got almost all modules for manufacturing. Okay. So it has got a lot of advantage over the conventional, like saving a material, improving the productivity, and getting a precision, tolerances and all that. So huge advantages are there when you go with the CAD-CAM. When we talk of conventional and CAD-CAM, even the academics are still conventional, because what we do is that we give a geometry with maybe a rectangle with corner, a fillet, a chamfer, a circle in between, a hole or something like that, and ask a student to do a program. So what programming is he doing? He is doing a conventional program. He is not using CAD-CAM. Our part programs which are there in the syllabuses are conventional programming. They are not editable. Rather, it is a very complex, tedious task. When the part which is in front of you, like a sprocket and all that, if you want to machine that using a conventional program, huge time waste. So the academics also need to be ramp up. Like many universities have come up with the new syllabuses where they have included the CAD-CAM into their curriculum. That's a very good part of it. But we should have always changes, because here what is happening, student is doing what? He is mugging up certain G codes, certain M codes, and then doing a trigonometric calculation. If a rectangle is 100 by 100, he is doing that calculation, x 100, then y minus 100, something like that. So there is no technology into that. There is something which is mugging up, putting it up into the codes, and we say that he has done very well in part programming. So is that program going to work in the current industry? No. Definitely a part of the G codes and M code he must remember, but the programming he has to do in a CAD-CAM software, not on the conventional. So the modules which might in a CAD-CAM includes design, 2D and 3D machining, which goes to the die and mold machining, then lathe, multi-axis machining, wire-ADM, router. Wire-ADM is non-conventional in machining, wherein the parts can be cut with a wire of 0.1 or 0.25 diameter with the electric current, which take a spark, and the spark produces more than 2000 degrees temperature in that zone, and the material get eroded from there. So router is almost like a milling, but used for the sheet metal parts or aerospace components. Design has got almost all facilities for surface, solid, curves, to do any kind of a modeling. Milling, as we said, that right from 3-axis to multi-axis. Application involves turbine blade machine, dyne mold, aerospace components, defense sector components and all. Okay. So this is one of the example what is shown there. What I will do now, the facing toolpath what we have seen just now, which was Akash has explained. Okay, so I'll just show you some. This is facing toolpath. This is a pocket toolpath, which is for roughing. Okay, then there is another toolpath for contouring, which is there for the machining or finishing of operations. Okay, so what we'll do, I'll just show a couple of these examples with the actual parameters being shown.
So coming to the next toolpath is our pocket toolpath. So basically, this toolpath is used for the clean out material from enclosed boundary using the specified depth of cut. So basically, this toolpath is used for the roughing purpose. And here, similar to the toolpath, there are some basic parameters like rough cutting methods, step over percentage, entry motions, and depth of cut, or linking parameters, etc.
Because
So
in
as
last
you can see,
toolpath,
there is a
most of
simulation
the
video
things were
for
explained.
this pocket toolpath.
Here we'll be going a little bit faster.
You can see the cutting method of this pocket toolpath, how it will cut that material.
In order to save time, we have just
Okay.
taken a circular pocket. But you can have any complex part.
So for
of
this,
engine.
just let me show you the Mastercam interface with this pocket toolpath. As you can see that here is a already existing material. On this existing material, I have to done pocket. So for the pocket, I have to choose this pocket, and by selecting the chain, I have to select that chain, and at this time I have to remind that thing the arrow direction. Okay, so this is our toolbar type pocket. Coming to the next, in select library tool. Suppose I have selected a flat end mill. Okay, according to your application, you can provide your cutting parameters, tool parameters, and what is the holder, what is the cut parameters. You can here you can see that stock to lever valves for the finishing purpose are. I just click on 00 because we don't need any finishing purpose. Okay, here, and here is the pocket types. You will get the pocket type standard facing. So the next roughing, in this roughing you will get some cutting methods like zigzag. Okay, I just select parallel. This is a step over percentage or step over distance. Okay. Come to the next. This is the entry motion, how it will be entry, and come to the next in finishing. If you want to do any finishing for the passes, you will provide, or you can provide that. And lead in, lead out. This is not necessary. I will tell you about this lead in, lead out, why we actually use that. And depth cuts.
With the time limitation,
1 mm.
we are trying to cover
Step to
a
down.
little bit faster. So
Linking parameters.
maybe in future sessions,
and
we
clearance
might
as per your
take
requirement.
in detail.
Okay, top of stock already you have did that
Actually,
testing
we don't
operation. And depth, what depth
regularly
you have to
come on
select
this
the
YouTube,
depth,
but maybe in
or
future
choose the
we'll try.
depth. Okay, and okay, so as you can see, this is our 2D toolpath. Okay. Just let me show you how it cut the material. As you can see, as per our given depth of cut value, it will cut that material. Okay, let me show you in 3D motion. So for the 3D, we have to go for this verify, and have to just start on play. and you can see how the material will be cut. Okay, so coming to the next operations is our contour operation. So for the contouring, we have to select the contour tool path. Here is the contour tool path, and by selecting chain, I have to select the chain for the contour operations. This is our chain. Okay, and after that you will get the same window. For the tool path, you have to select the contour, and I've selected the same tool, flat end mill 10 diameter, and go for the cut parameters. Here you have to define compression direction on which side that will be go. Okay, and here is the stock to leave on walls, stock to leave on floors, and go to the depth cuts. Okay, keep hold down. Leading lead out. Here this leading lead out is needed. Okay, and if you need any multi-passes, then you can also provide that. Coming to next in linking parameters. Okay, just provide the value and depth. Okay, let's see, because we did the cut parameters the right, and okay, so you will get the contour bar. So after that we will go for the next operations is our drill. So for the drill we have to select the drill 2D drill tool path. Okay, and by selecting this mask on arc we have to select just or find out the arc. After that just drag on that and drop, and by selecting the order you can define the order. Okay, same as it is. You go for the tool as per your diameter. If there are any availability, then it will be easily identified. You will get there are a lot of types of tool, and this is our drill. Okay, 10 diameter, that is availability of the 10 diameter drill tool. And go for the holder, select the holder, stock, no needed, cut parameters, why or what type of cycle you want. I want if you want to pack drill, then just click on the pack drill and give the pack value. Okay, and go for the linking parameters. Active the clearance and retract, and go for the top of stock and depth. How much depth do you want? As you can see, this is our depth. So I just given that. Okay. This matter until truth path is generated. And so now I will show you the whole operations in a 3D simulations window. Okay. Just click on it and regenerate all toolpath and go for the verify. And here you can stop condition. You can apply the stop condition by choosing the operation change, and you can also give the curl loop by operations and just start it. Just a minute, I didn't. Okay, now start. So first facing operation is done. Next is our pocket operation.
फोन पे अगर उनको लेना है इंडस्ट्री एक्सपोर्ट्स को तो कैसे लेंगे?
Okay.
फोन पे only phone.
And next operation is contour. Here you can see that in information.
अरे फ़ोन अपना फ़ोन पे कॉल कर रहे हैं ना अपन, स्काइप के जगह पे ओनली फ़ोन पे कॉल कर रहे हैं, फ़ोन
Okay.
मोबाइल से।
Next operation is our drill.
इसमें हाँ
So this is it. The whole operations.
देखो एक
So
फट से
how the NC codes will be generated? So for that you have to go to this post selected operation, that is G1 symbol, and click on that just, and click on the NC file, just click OK. After OK you will get a window for saving file, the root. Okay. After that just click on save, just replace it out of the previous operations, and you will get a Mastercam code export window, and here you will be able to find your ANSI codes. Here's the ANSI code generated. Okay. All the operation that you have done, you will get the all ANSI code very easily within a short time. Thank you. So coming to the next is our contour tool path. So basically using this contour tool path we can remove material along a path or defined by a chain curves. So contour tool path was only follow a chain, they don't clean out an enclosed area. So basically this tool path is used for the finishing, either pocket or core. Okay. Similar to that, there are some basic parameters like cut parameters. In cut parameters you will find, or you will get depth cuts, lead in, lead out, multi passes, and leaking parameters. Let me show you the cutter tool path simulation video. Yeah, as you can see that how it cut the material, like follow a chain. Okay. Let me show you in Mastercam interface how it work exactly. So for the contour tool path, I have to select the contour. Okay, same. I have to select the chain, and just notice that the arrow directions. Okay, whenever you click or select the chain, and after that go for the toolbar type. Go to the tool, select the flat end mill up 10 diameter. Go for the cutting parameters. Okay, or here is the composition direction according to your chain follow. Okay, and if you want to stock to on leaves or walls, you can provide that. After that go to the depth cut, and you can provide the depth cut, like I have just defined that 0.5 and keep tool down. Go for the lead in, lead out, and just activate. Okay, after that go for the linking parameters and clearance. Here provide the clearance value and dictate value also, and top of stock we have already done that. So just click on 0 and go for the depth, select the depth value,
Hello.
how much material will be cut, and just click on OK. As you can see, this is my 2D contour toolpath. Okay, and let me show you the 3D simulation window how it work actually. So this is our 3D simulation window. As you can see how it cut.
Hello.
Just let me show you
एक
in
मिनट
slow
में
motion
आपको ऑडियो कैप्चर करने के
how
लिए
the
चेक
lead
कर
in
रहा
lead
था,
out
इसलिए मैंने
work.
आपको ये किया।
Just watch.
1 मिनट।
Okay. Outside.
हाँ क्या? एक मिनट।
Inlet.
1
Again
मिनट।
in
Now is it
inside.
audible? एक मिनट। हेलो।
Like this it
Hello.
work. Let me show you the in 2D toolpath.
हेलो। हेलो।
Just see
हेलो।
from the top view. This is lead in, lead out.
हेलो।
Okay.
हेलो। 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 Is it audible? हेलो। 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 हेलो।
So coming to the next is our control path. So basically, using this.
Good afternoon, everyone. Let me introduce you to Mr. Nitin Vakode, Director of Deccan IT Technologies, Skyleap Tech.
Hello. Hello. Yeah, I think there was. Yeah, I hope each one of you has enjoyed the session. Uh, because of the time limitation, because already we exceeded time because of the initial technical clinches. There are many things in CAD/CAM which can be covered. So we expect to get back to you again with a program with more information on CAD/CAM, and try to have your understanding, involvement. Okay. But as we can see that though we are on a YouTube, but it's not that we are very much regular, but we will try at least once in a month. We'll try to bring at least some new technology areas when certain new machines are launched or certain new softwares are launched or certain new things are available. In that scenario, we'll definitely try connect with you, try to have certain joint programs. uh, we even actually try to do some sort of uh, MOUs if certain institutes want to do in terms of projects for the students, certain internship for the students. We keep on doing that. Since last many years, with the requirement of academics, we always try to uh, satisfy that. And in past couple of years, many industries have come up like that. We did that. We want to keep involving, because it's not always that we should expect certain things from academics. We should also try to give something to the uh, academics. So in that scenario, we would like to add such kind of a things, and we hope definitely that will add value to the academics. One minute, I'm hello. Okay, I think there is this one, so no problem. So